Hi, welcome to video 5.5 on solving quadratic equations using different methods. So we're going to take a look at this equation right here and look at different methods that we could use to solve it. So the first thing that can be helpful to do is look at our discriminant, which is b squared minus 4ac. It's the stuff under the radical in the quadratic formula, and see how many solutions our equation has. So our a is 1, our b is 2, and our c is 1. So that means that b squared is 4 minus 4, and then our a is 1 and our c is 1. So this means that 4 minus 4 times 1 times 1 is 0, and if we have 0, then we only have one solution that we're looking for. And then we're going to solve it a few different ways and just take a look at which one's easier. So this one, if we're looking at x squared plus 2x plus 1, I'm going to put my 0 over here. And my factors and sums, this has a leading coefficient of 1, so I'm just looking at my factors being 1 and my sum being 2. So my factors are going to be 1 and 1. 1 plus 1 is 2. So we're going to do x plus 1, and that's the same thing as x plus 1 squared equals 0. And then when we're solving it, we put x plus 1 equals 0, which means x equals -1 in that case. Okay, for this one, completing the square, this one, it's already done for you. This is already a perfect square trinomial, which we can see from the factoring. So I'm just going to put that this one is already done. But this is an anomaly. The majority of time, completing the square is going to look different than factoring. And then the last one, solving by the quadratic formula. So x equals, negative b plus or minus the square root of b squared minus 4ac over 2a. And so x equals negative b is going to be -2 plus or minus. And then we already know that this is 0 because we did it up there, over 2 times a is 1. So square root of 0 is 0, 2 either plus or minus 0. It's going to be -2 over 2, so that's -1. So which method was easy for me? I would say B/C, because they're really the same in this case if you recognize that that's a perfect square trinomial. So those are the same in this case. And I would just say in this case, for me, it's less work / less confusing. The quadratic formula is not bad to do, but it's not my favorite because it's just got a lot of icky calculations in it, whereas if I can factor it fairly easily, then that's the solution that I usually go for. Okay, so now turn the page, and here are 6 questions that you should be able to answer at this point in the chapter. So go ahead and pause the video and give those a try, and then come back and take a look at my answers. Okay, so here are the answers for this one. Oops, I forgot to circle it here. This should be this one right here. So that's C, 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 A, C, and B. And if there are any of those that you have questions on, you can just write them down and we will go over them in class next time. Okay, let's look at the next page. We're not going to do 8 because it doesn't make any sense. On this one, we're going to write a quadratic equation such that the sum of its roots is 6 and the product of its roots is 27. So it's kind of like a factor sums table. If we want its factors to be of negative 27, that's product, and then we want the sum of its roots to be 6. So I'm thinking 3 and 9 right now, so like -3 and 9, and if I add those together, I get 6. So that works. So that means that we're going to do x minus 3 and x plus 9, and that's going to give us 0, because we want a quadratic equation, and then we're just going to multiply everything out. So x times x and x times 9, x squared plus 9x, and then -3 times x and -3 times 9. So minus 3x and then minus 27. So then when I combine my like terms, I get x squared plus 6x minus 27 equals 0. And so that's my final answer on that one. Okay, we're going to look down here. And on this one, we're looking for determining the roots for each equation, and we're going to find the sum, difference, product, and quotient of these roots. And this one is easier, so I'm going to have you guys do that yourself. And this one is a little bit more difficult, so we're going to do this one together. So we're going to do a factor sums table on this one. Our factor is going to be 7 times 4, so that's going to be 28. And our sum is going to be 29, which means that if I do 28 times 1, I get 29. And so I'm going to rewrite this middle part as the 28 and 1. So I have 7x squared plus 28x plus 1x plus 4 equals 0, and then I factor by grouping. So I'm going to take out 7x in the first part, so that's just going to be x plus 4, and then in the next part I'm going to take out just 1 so that I have x plus 4 equals 0. So now I have 7x plus 1, and I have x plus 4 equals 0. So now I'm going to split that up. 7x plus 1 equals 0, and x plus 4 equals 0. So here, subtract 4 from both sides, and I have x equals -4 over here, minus 1, so I have 7x equals -1, divided by 7, x equals -1/7. So my smaller root is going to be -1. Oh no, I'm sorry, this is -4. So my greatest root is going to be -1/7, and my least root is going to be -4. And so if I add those together, then I'm going to get -4 and 1/7. If I take the difference of those, so 4 minus -1/7, then that's basically plus 1/7. So I'm going to have -3 and 6/7. If I do the product of them, that's -4 over 1 times -1/7, which is just 4/7. And then the quotient of those is dividing them. So I would take -4 divided by -1/7, which means -4 times the reciprocal of this, which is -7. And then -4 times -7 is positive 28. So my answer is positive 28. Okay, you guys pause the video and go ahead and try the top one there, which is a little bit easier. Okay, here's the answer for the top one. So least root -4, greatest root 4, 0, -8, -16, and -1. Okay, moving on to the back page. So the next thing that we're going to be doing, our next chapter, thinking ahead a little bit, is going to be getting more specific into quadratics. So drawing them, their specific characteristics. So we're going to do a little bit of a connection between what we've been doing and moving on to that. So I'm going to leave the first one for you to do, and we're going to do the second one together, because the second one is a little bit not as pretty when it comes to the actual calculations. Okay, so our A here is going to be -3, our B is -8, and our C is 12. Our leading coefficient is -3. Our leading coefficient is going to be negative. And then if our leading coefficient is negative, then our graph is going to open down. And I'm going to go ahead and put up here that when the leading coefficient is positive, because you're going to have a positive leading coefficient, if your leading coefficient is positive, your graph is going to open up. Just like our parent function, y equals x squared opens up. It looks like that. Okay, so down here on the bottom are roots. I'm going to go ahead and do the quadratic formula for this one. So I've got negative b plus or minus the square root of b squared minus 4ac over 2a. And so that's 8 plus or minus 64. Negative 4 times negative 3 is positive 12. Times positive 12 is going to be plus 144, which altogether is going to give me 208. And then that's over negative 6. I put both of those into my calculator, and I ended up getting that the roots are approximately negative 3.7 and 1.1. And so I'm going to draw that on my graph. So right here, there's negative 1, 2, 3, 4. So negative 3.7 is about there. And then there's 1 and 2. So 1.1 is about there. And then it's going to open down. So the graph I can do right now, I'm going to draw a parabola that opens down and has those roots. And having those roots means that it meets the x-axis at those points. Okay, so you try it up here, find the roots, and then you're going to mark the roots on the x-axis, and then it's going to open up like that. Okay, so here is the answer when you're finished. It looks like that, and that's a really rough sketch. So as long as yours is opening up, and it is touching our x-axis at negative 3 and negative 4, then you're good. You did what you need to do. Okay, write down any questions that you had, and we'll talk about them in class.